Good morning, afternoon, and evening, everyone. My name is Melvin Fardiman, presenting on behalf of my co-authors, Esther Simoninja, Marta Bernica Wijaya, Mariani, and Sana Subut, from the School of Information System and Entrepreneurship at Bina Nusantara University, Malang. Our paper is titled AI-based demand forecasting for pharmacy inventory management, a prototype development approach. Let's start with why this matters. Indonesia's National Health Insurance Program, or known as JKN, has widened its access to healthcare, which means more demand for medicine at the pharmacy counter. At the same time, Indonesia's archipelagic geography makes procurement and distribution generally difficult. And underneath both of these pressures, most retail pharmacies are still doing demand forecasting manually. Together, these three conditions make a systematic, data-driven inventory management a growing operational necessity. So what does that manual approach actually cause? There are three root causes. First being forecasting is still done by hand or manually. And then there are no automatic alerts for low or near expiry stock. And transactional data isn't being used for demand analysis. The consequences are serious. Stockouts that can mean treatment failure, overstock that leads to expired medicine and financial loss, and it doesn't stop at the pharmacy level only. These errors amplify upstream from pharmacy to distributor to wholesaler and to manufacturer. This is the classic bullwhip effect. A small forecasting error at the counter becomes a much bigger, costlier distortion further up the supply chain. Looking at the literature, machine learning models such as random forest, SGE-Boost, LSTM, and GRU clearly outperform traditional forecasting methods. But here's the gap. Most of these studies stop at nodal comparison. Very few translate into a practical, usable prototype that integrates forecasting, stock monitoring, and procurement recommendations into a single system. So, our objective was threefold. The first being to identify the real inventory challenges pharmacies face, design and evaluate an AI-based forecasting prototype, and provide a practical recommendations for adopting AI in pharmaceutical inventory control. The solution. Our answer to that gap is Pharmacists, a web-based decision support prototype built around three main pillars, being AI forecasting, which uses machine learning to predict future stock from historical data. Smart alerts, which automatically flag low stock and near expiry medicines, and procurement support, which turns those forecasts directly into purchasing recommendation. To build this, we use the prototype method with 5 continuous steps. First being communication, which is the field observation at partner pharmacies to surface real problems. Second, being quick planning, defining scope and requirements. Third, modeling and quick design, in which we create low fidelity wireframes and UML models. Fourth, construction, where a high fidelity Figma prototype was created. And fifth, deployment, delivery, and feedback, where we run user acceptance testing against each requirement. This loop repeats so the design keeps improving based on real user input. Data structure. On the data side, our class diagram centers on 6 entities: user, medicine, purchase detail, and forecast, and history. This structure ties every forecast directly back to real transactional data. So, predictions aren't happening in isolation. They are grounded in what's actually moving through the pharmacy. The system supports three user roles known as warehouse staff, which can log in, manage the dashboard, and add products. The pharmacy manager, which can review forecasts, approves purchase orders, and checks transactional history. And lastly, admin, which maintains data accuracy and supports procurement documentation. One shared workflow, three distinct responsibilities. Next is navigation. Navigation is organized around four core modules. The first being home, which gives an overview of everything. Next is demand forecasting, where forecasts are run, viewed, and saved. Next is inventory for item lists, details, and stock updates. And finally, purchasing for draft and submitted procurement proposals. All of it connects back to a single sign-in flow. Forecasting, here's what it actually looks like. The dashboard gives a real-time inventory, visibility of low stock flow, and near expiry highlights, all at a single glance. The forecasting page predicts demand for every item based on historical sales, and every save forecast can later be checked against the actual outcome, so we can track accuracy over time. The inventory module shows the full item list with color-coded status, stock level, and expiry indicators. Users can drill into item detail, name, category, price, quantity, expiration, and add new drugs through a single form. Next is purchasing. This is where the loop closes. Purchase suggestions are generated directly from the AI forecast output, so procurement decisions are tied to actual predicted demand, not guesswork. Users can track a purchase from draft through submission to fulfillment, and history and reporting record every transaction along the way. User acceptance testing. Now, does it actually work for users? We tested with 41 users across 10 scenarios, which means 410 total responses. The overall result, a 95.37% pass rate, which means 391 had passed and 19 had failed. Under our feasibility scale, that qualifies as very feasible, which means ready to proceed to implementation. Looking at the breakdown, login and dashboard hit a perfect 100%. The lowest scoring features are AI forecasts and reports, still passed at over 92%. So, across the board, the prototype held up really well. Next, digging into where the friction had happened. Most failures clustered around AI forecasts, with 6 failed responses and inventory with 5. But importantly, these failures point to interface and navigation issues, not broken functionality. Things like button visibility or unclear feedback, the kind of usability refinements you'd expect to catch and fix in a design iteration, not fundamental flaws in the system itself. To conclude, we built a high fidelity prototype integrating 6 modules with AI demand forecasting at its core, and it achieved a 95.37% UAT pass rate, confirming both functional and readiness, and a strong fit with real pharmacy business processes. For our future work, we plan to integrate real forecasting models like LSTM and XGBoost, evaluate them with MAE, RMSE, and MAPE benchmark against conventional forecasting techniques, run larger and longer term field testing, add an economic impact analysis, and explore supplier integration and inter-pharmacy stock sharing. That concludes our presentation. Thank you very much for your attention.